to see how this is going to work. Alright, let's go for it. 3.1. Just a quick review. Example number 9. We're just going to keep on going. Question on that. Alright, so first things first, on the question is where does V come from? Well, V is this little graph right here. It's y equals the absolute value of x. So if you were to graph this by hand, you'd say absolute value of 0, 0. Absolute value of 1 would be 1. Absolute value of 2 would be 2. So you get this sort of line right here.
So what do you, so y and x are both 0? It should be 1.
No, I'm making a table in my head. I'm doing this.
Oh, okay. Well, then, yeah.
0, 0, 1, 1, 2, 2. And then I can repeat that, just kind of keep it on linear alignment. If I go to the left, I go negative 1. Absolute value of negative 1? Positive 1. So I put a 1 right here. Absolute value of negative 2?
Yeah, because that's what it's going to make with V, right?
Yep. So absolute values always make this little V line.
Absolute value.
What they want you to realize is this. What happens if you put a little minus 4 at the end?
It's 1 or whatever number you want for x minus 1.
It's this graph itself just taking down 4 units. So everything is 4 units lower. Good there? Because what you're
going to be 0, 4?
Almost.
Negative.
Good.
I mean, negative?
Yep, it'll be 0, negative 4. So instead of 1, 1, it'll be 1,
And then 4 down.
negative 3. Instead of 2, 2. 2, negative 2. And I'm going to try to graph this the same way here. It should be the exact same line.
If the x was a number, if the x was a 1, if the x was a 2.
Yeah, so if I did it this way, I put a 0, it would be negative 4. Put a 1, absolute value of 1 is 1, subtract 4 is a negative 3. Then I go with the negative 1. How about negative 1? Negative 1, absolute value of negative 1 is still positive 1. Positive 1, subtract 4 is still a negative 3. So I got this line here. And I got this one, and I give myself a graph that looks like this, but more straight.
So that's only with an absolute.
Yes, yeah. So absolute values, they always give this little, it's like a V shape.
Oh.
But what they want you to do on homework number 11 is this right here. So let's go 3.1, number 11. Let's go down to homework. They give you 2 graphs. First graph in red is like this. Right? Then they give you a blue graph, which is like this. And then they give you the equation of the red graph already. The red graph equation is y is equal to absolute value of x. And then they say, based upon the equation of the red graph, can you give me the equation of the blue graph?
Well, the red one is like 0, 0.
Yeah, so that one is absolute value of x. But what's happening to the blue graph from the red graph? We go...
Negative 3.
Yeah, it just goes down 3 units each time, right?
It goes down 3 units, and then it goes up, 3, 3. So it'll be negative 3, 3. It's like negative 3.
Well, let's see. Positive 3, 3 goes up here, right? For the red graph. But for the blue graph, it's positive 3, 0. It's always 3 units lower.
What I didn't understand on those is, are there 3 points? Is it like 3? Is it like negative 3, 0, and then 0, negative 3, and then 3, 3? Is there like 3 points on those, or are they still only get 2 points? Not the with the little circle.
The points.
There's 3 points on it.
Yeah, the points are here everywhere. Points are everywhere. Which you may want. What the book wants you to realize is the fact that from the red graph to get back to the blue graph, you have to go 3 units lower. So instead of being at 1, 1, now you're at 1, negative 2.
Oh.
Instead of being at 2, 2, now you're at 2, negative 1.
So we're just looking at the 3. I mean the negative 3.
Yeah, we're looking at the distance between the two.
Oh, okay.
Okay. No problem. And then what you want to realize is, okay, if the equation of this guy is absolute value of x, what's the equation of the blue graph? The equation of the blue graph would be absolute value of x, subtract 3, because we went down 3 units.
Yeah,
So
so
you're
what if then up and
perfect, yeah. If the graph started the V shape up here, 0, positive 3, and it went like this, then it would be absolute value of x plus 3. So you're just trying to see the shifting of the graph.
Oh, okay.
It's okay? That's why you say light bulb. That's
Yeah.
cool.
another thing that I need to help is that I tried looking for it, but there was a perpendicular calculation.
Okay.
Yeah,
Take a look at that.
didn't have a perpendicular.
On
It
3,
just like had it came with the equation underneath, like for you to go swap these as reference. Well,
they tried. Page 166.
yeah. Well, they tried, but I mean it doesn't.
Uh-huh. Let's see if we can.
Trying doesn't help.
Yeah, let's see if we can handle that one over here. So 3.2, number 21, 25, 37. Raise your hand if you have not signed the sign-in sheet. Just real quick here. Talk to me. Okay. Okay, 3.2, number 21. Alright, this one's a little different. This one is on the online homework. Yeah. The only thing is, it was not covered in the textbook. It's one of those questions where you didn't cover, but you should realize, like, oh, I could do it like this, sort of thing. So, 21 says, I'm trying to find out A. What I know about this is, I know these 2 points are there, and then I also know that the slope is equal to negative 1. So, if you think about still the slope formula. Slope formula is this right here. And since you guys are sophisticated Math 63 students, the author says you guys should know this. So we're going to plug in everything we know. So m is equal to negative 1. That plugs in as negative 1. So now let's see what happens here. It's going to be y2 subtract y1. So that's going to be a 6 subtract 3. This would be x2 subtract x1. So this would be a 2 subtract x. Okay, A's better. Cool. Alright, and then our goal here is to figure out what A is. Alright, so let's simplify at least as much as we can here. 6 subtract 3 is a 3. That simplifies there. This one does not simplify. Can't put a 2 and an 8 together. Okay, now what we do. Probably the easiest way to do this, from chapter 2, since we learned how to solve equations, we're going to make this into 2 different fractions. And remember, as soon as we get 2 different fractions equal to each other, we can cross multiply. And I want to multiply the one with the 8 first. So it's negative 1 times 2 minus A is equal to 1 times 3. Alright, and then solving for A. So how about a negative 2? How about a plus A is equal to 3? And we've solved it. Found out that A is equal to 5. That's what makes these two. So that should have been a 5. So let's see. 1, 2, 3, 4, 5. 1, 2, 3. If this dot was here, as opposed to any arbitrary A, this dot was 1, 2, 1, 2, 3, 4, 5, 6. So notice, if I go down like this, does that give you a slope of negative 1? That's kind of what we're looking at here. Cross multiplying because I've made 2 fractions equal to each other. And I can cross multiply as long as I have 2 fractions equal to each other. Anytime. Don't need to do the graph, no. That was just to sort of show you. So if this dot was 2, 6, the only A that works with a y value of 3 would be A equals 5. show the graph so it makes sense to you. Cool. Okay. 25 is the next one. 3.2, number 25. Again, was not in the notes, but you need this in order to do the online homework. So those people that just left, it'll be fun when they start their online homework. I can see the emails. Mr. H, how do you do it? I did it in class. Okay. y2 minus y1, x2 minus x1. Let's go for it here. So 5 goes here. y2, ooh, this is a toughie here. So y2 is x squared, subtract 4. On the bottom it's x, subtract 2. Cool there? Can't simplify that at all. And you probably don't want to factor because you're going to lose one answer over here. So what we want to do, over 1, and let's cross multiply. You know what, I'm going to multiply this one here. I'm going to multiply the one to x first because I like the x squared. So I'm going to, it's 1 times x squared minus 4 is equal to 5 times x minus 2. So let's see, x squared minus 4 is equal to 5x minus 10. So let's move this to the other side. So yeah, I heard someone say factor. Absolutely. We got to move everything over. Set equal to 0 first though. And we get ourselves x squared minus 5x. So what is that? Let's see, it's a negative 4 and plus 10. X minus 2, x minus 3. I already did that, right? Then we have x is equal to 2, x is equal to 3. You know what? As I'm thinking about this here, you're right. Since this is a fraction, before we could do this here. Before we start this problem even, we say what's in our domain? What can x not be? As I'm thinking about it. X can't be a 2. So then we go over here and we start solving for stuff. We reject this. Another way you can think about rejecting is this. Once you plug this in, look at this here. Once you plug it in, isn't this the number 2, 4? What happens here? This is a 2 and that would be a 4. If you plug it in, it wouldn't make sense because you got the same dot. Like, that wouldn't make sense. That would not give you a slope of 5. So the only one that you would have to accept is x is equal to 3. Okay, good there? Maybe, sometimes. Yeah, So we started this problem right here. There was a domain problem before we started right there. Anytime you have fractions, anytime you start solving stuff like this, x can equal 3, x can equal negative 5, x can equal negative 7. It's only little issues on the bottom, that's the problem. Let me see what it asks for. Let's see. Solve for the indicated variable if the line through the two given points has a slope of x. So at this point, the answer technically is just x equals 3. Because we already know that you're going to take that 3 to the square to give you 9. So it doesn't say tell me the coordinate, it says solve for the variable. Okay, good there? Keep on going. Check 37. 322, number 37. Perpendicular lines. Line L contains the point 5, negative 6, and 5, 2. Give the slope of any line perpendicular to L. Ooh, fun one. Okay, this is a tricky one. Numbers we can do. So y2 minus y1, x2 minus x1. subtract a negative 6. Kind of careful there. Now on the bottom it's going to be a 5 subtract 5. And then we do this. Undefined. Let's see, so a few things. Depending what math book you're talking about, some people say you have an undefined slope. Our math book says you have a no slope. But, real quick here, because that's not what we want yet. What kind of a line has a no slope? So, a vertical line. In fact, it passes through 1, 2, 3, 4, 5. It's kind of like this. So now the question is this. Any line that's perpendicular to this line would have a slope of what? Yes, any line that's perpendicular to a vertical line will have to be a horizontal line. And horizontal lines have a slope of 0. Ah, tricky one. If you got that one, you did good. There's a lot of concepts there that you get. Yeah, slope equals 0, m equals 0, whichever.
So that's how you solve this equation?
You figure out the slope that you have for the 2 points, and then you take the opposite reciprocal. So let's say this actually became 8/9. Perfect. Yep. That's okay. So opposite of this. So remember, that's just the slope of any perpendicular line, right? Of any line that's perpendicular, like there's a whole bunch of horizontal lines that are perpendicular right here, right? But all of them have a slope of 0. So you can have a whole bunch of different perpendicular lines like that one there. Maybe let's say it goes like this. But again, a whole bunch of different perpendicular lines. All slope has to be at this point a negative 9/8. All of them have a negative 9/8 slope. If this one has a slope of 8/9.
So whenever they ask you
good opposite reciprocal, right? Changes the sign as well as the number. Take reciprocal of that. Right? Cool, alright, 3.3. Let's go for it. 3.3, number 7, then number 37. Number 7, find the slope of the line that's parallel, and then find the slope of the line that's perpendicular to this guy. Okay, so now instead of 3.2 was dealing more with points, individual points, and the whole concept of slope formula. 3.3 now moves on. Now is equations. And so what we have to realize is we're in this equation. If you have something solved for y, this guy is the slope of this line, this guy is the y-intercept. Chicken scratch over here. So we've got to do A. What's the slope of the line that's parallel to this line? 3 or 3/1. It's just the coefficient, and then don't include the x, because the slope is just the m. It doesn't include the x here. It's just the coefficient of the x. And then B.
I think what happened is I put the x, you don't know, x in the end, and they didn't want the x. They just want a number or a letter.
Okay, I need now the slope of the line that's perpendicular to this line. Yeah, negative 1/3, and you can put the negative in front of the fraction, you can put the negative on top of the fraction, either or. You normally don't put a negative on the bottom. So, one of those. Actually, I should say or over here. This one or this one. Just be fine. Okay, good there now with number 7?
On number 7, when we graphed it, I had graphed them and they told me I didn't need to graph them. But I would, see if it was perpendicular, how do you know it's perpendicular? So if we see this, would we know it's perpendicular lines, or we have to do the opposite?
You got to do the opposite reciprocal.
And the parallel is just going to be the 3.
Yep, this is the same exact thing. Because parallel lines have same slope. perpendicular lines have opposite reciprocal slopes.
When you ask them on the one or the other.
Yeah. Alright, 37. Now the slopes, let's see, find the equation on line. Okay, some fun stuff here. 37 says find the equation of a line. Find equation. Whenever you see that and you're talking about a line, find equation of a line, automatically in your mind you should say, oh yeah, that is y minus y1 is equal to m times x minus x1. That's should be in your mind, because that's what will give you the equation of a line. Point slope form. Yep. Except what has brackets? The slope is kind of hard to figure out. So let's go for it here. So m is equal to, again, y1 subtract, I'm sorry, y2 subtract y1, so negative 1 subtract a negative 1/5. And then negative 1/3 subtract a negative 1/3, so negative 1/3 subtract negative, oh sorry, positive 1/3 over here for this one. Ooh, let's see what we got here. We got this and this, first of all. Now I need common denominators for the top. So everybody okay with 5? Negative 5? And that's a 1 still, is that right? So how about a negative 4 over 5 for the top? Ooh, bottom's okay still for that. Right, because you're subtracting a positive, which means adding a negative. Common denominator is already here. So negative 1 plus a negative 1 is negative 2, and that just carries over into here. Okay, we saw something like that in chapter 1. If it's like this, what that really means is it's a negative 4/5 being divided by a negative 2/3, which really just means negative 4/5. Yep, change to multiply, take the reciprocal. And doesn't matter where the negative is, eventually positive. Good, good. Canceling, is that right? There, okay? Oh, we have people writing it down here. Let me wait just a little bit. Huh? Yeah, just reduced. Yeah, reduced 2 and 5. 2 and 4. Okay, so 6/5. Or else it would have been 12/10, right? Yeah, it's been reduced. Okay, so all that work was just to get us the m value right here. That was all that work was for right there. Now what we have to do is we have to plug in this formula. So we got to use one of these points. So you guys tell me. You guys want to use this first one here, or you want to use the second one? Second one, less fractions to deal with. I go with that. Okay, so let's use the second one. Negative 1/3 and negative 1. Why can we use either or? Because both of them are on the line. So it doesn't matter. We just need a single point that's somewhere on that line. Okay, let me see if I can fit this all into here. So y1 is this one over here. It's a negative 1. So y subtract a negative 1 technically is y plus 1. The slope, yeah, I already know that. That's what I did to calculate it. So 6 over 5. And this is x subtract x1, which is a negative itself. So how about a plus 1/3? Everybody good there where the numbers came from? Alright, it also says write the answer in standard form, which we'll talk about in just a bit, because that's the other form that we need. So first of all, let's distribute that 6/5 here everywhere. So that means this is a 6/5 here. You guys can do that. You guys are sophisticated math 630 students. 15. Okay, so let's talk about it. If it said write in slope-intercept form, we would subtract 1. But it says he wants to write in standard form. Standard form means ax plus by equals c. We covered that last time. There's standard form. Standard form, the variables are all on the left-hand side. You got one single constant here, and what happens here, there's no fractions. We don't want fractions anywhere in ABC. So first things first, looking at this problem here, let's get rid of fractions. What should we multiply by? 15. Let's multiply everything through by 15. I'm going to still try to squeeze it in here. So let's see, 15 times y. 15 times 1. Ooh, this is fun. 5 goes into 15 3 times. 3 times 6 is 18x. And then 15 goes into here. And 15 is canceled, leaving you just plus 6. Alright. Good there so far. Got people like looking at me like they saw a ghost here. Talk to me. How in the world? Okay. Let's do this here. I'm going to subtract 18x to bring it over to the left, and I'm going to subtract 15 to bring it over here, so we can see if we do that on one step. So negative 18x plus 15y. Everybody good there so far? If I subtract 15, bring it over here, what's that number going to be? Negative 9 is good. And I got to check out something. Okay, so a few things here. First, in standard form, all these numbers have to be, we call it relatively prime, which means there's no number that goes into all of these. So if you can divide all those numbers by some kind of number, do it. Yes. So 3 can divide each of those numbers. So we don't leave it as negative 18. So that would be a negative 6x plus 5y is equal to negative 9. That's one issue. And then let me check the definition once again just to make sure. Everything gets divided. So negative 9 went down to negative 3. Okay, some math textbooks allow you to leave it like this. So I'm just checking some answers here. Even though the book does not say it. Most algebra textbooks, they want the number in front of x to be a positive. So we're going to multiply through by negative 1. We're good there. So this is a positive 6x minus 5y is equal to a positive 3. Now, some algebra textbooks, this is just fine, and they leave it there. Some algebra textbooks make you go down to this one right here. Your book, even though it never says it anywhere in the book, it always brings it down to this one right here. Fun, fun, fun. They did talk about the relatively prime, though. That's kind of good. Such a fun thing. Let's see. Da-da-da-da. Yeah, to the positive. And let me just see if they do anything like that. Yeah. So all the examples they give, the x always turns out to be positive. They never turn out to be a negative. Yeah. Hopefully on the test, I haven't seen the test yet, but hopefully on the test all of the x's are positive, then you got to choose which one. So that'll be at least a fair. Oh boy. Okay, we good? Homework is done. Any other questions? Okay, so let's do this here. Those are yes. That's how it's going to be online, yeah. Yeah, so again, paper, pencil homework is just to prep you for the online homework assignment. So all we did, you bet you will see a question very similar to that online assignment. Uh-huh. Okay, so let me do this.